internet consumption, so internet access and internet consumption, being the internet a very massive presence in our everyday life. How can we ensure to measure within the footprint of the internet remains also from a technical point of view a major issue. And finally, the fourth working group is more focused on aspects that relate to communication networks. So ICT as a big bulk of technologies includes indeed the capability to connect to each other, devices, things, sensors, people, applications. And in this respect, also the way advanced communication networks are serving this infrastructure, are providing this infrastructure is crucial in order to optimize its energy consumption. I think, and we probably will discuss this today, it's not a matter only for technologists. We have to make sure that everyone in the society plays its role. Economists, financial operators, but also policymakers, regulators, and users. Finally, all end users and consumers must become better aware. Clearly, there are obstacles related to lack of investments or still limited lack of investments, and also fragmentation of regulations across different countries, because as a matter of fact, ideally, we should treat this as an issue that has no borders. So today I'm looking forward, I will end up here. I could talk much more, but I'm looking forward to discuss with you guys how we can better tackle some of these issues. Thank you.
Thank you very much, Monique. Bernard, you are at the forefront of digital transformation. The automotive sector is one of the sectors doing most of the innovation lately, really not only at the forefront of digital innovation, but at the edge, because in the end, a car is at the edge of our network. Can you tell us how you're tackling with the green aspects in your sector?
Yes. So good afternoon, everybody. My name is Bernhard. I'm Innovation Manager in AVL. We are based in Austria. We are a family-owned business with around more than 10,000 employees worldwide. We are acting as an independent engineering solution provider to OEMs, tier ones, and other players in the automotive value chain. And having this perspective, I hope that I can contribute a little bit to the discussion today. Taking the perspective of the automotive industry, I think it's worth to mention that the automotive sector is one of the key industrial sectors in Europe. Just to give you a number here, we are creating more than 13 million jobs in Europe. There is, let's say, as mentioned by Federico, a ongoing transformation process, that poses quite a big number of challenges. There are major challenges that we have to address in the near future. Just to mention a few very prominent examples, of course, the reduction of pollution emissions is one of the major concerns. Also, if you look at the accidents, then we still have to focus on the reduction of traffic facilities. The introduction of automated driving system goes strongly in that direction. And of course, if you look at on a more broader perspective on the demographics of Europe, the baby boomer generation is going to retire. We are more and more faced with an aging population, not only in Europe, but particularly in Europe. And there is an increased need to support mobility for this kind of aging population. So there are numerous challenges that we are faced with. Bringing that down to, let's say, the major trends on an engineering, from a point of view of an engineering perspective, I think there is need to mention at least four major trends that, in my opinion, are also mutually enforcing trends. Trend number one is the electrification of powertrains. transitioning from the internal combustion engine to fully electrified cars, hybrid cars being some solution in the middle. Of course, the second trend to mention here is the advent of autonomous driving functions. Automated driving assistance systems are coming on the market in order to reduce, for example, the number of traffic fatalities. Well, and then as a third trend, I'd like to mention the fact that vehicles become more and more connected. So we can connect the in-vehicle data to some backend and set up some kind of applications on top of that connection. Think on all the communication between the vehicle and the infrastructure and the vehicle to the vehicle V2X and V2V communication. And as a last major trend, I'd like to mention smart mobility. I like to call it responsible mobility, as the focus is more and more shifted to sharing of vehicles in order to reduce also the ecological footprint of vehicles. And in all of these four trends, I think that the digital transformation and particularly the edge and the trade-off, what to compute on the edge and what to compute on the back end, is a cross-cutting enabler to these four trends, so that these four trends are mutually enforcing each other. And I'm happy to discuss this with you today. Thank you.
Thank you very much, Bernard. Babak, you have been not only professor at the PFL, but you have also the funding director of EcoCloud, an initiative clearly related to the sustainability of clouds. What is your experience in the area and how things are changing?
Thank you very much for having me here. And let me just share the screen real quick so I can present a few slides. Do you see the presentation mode slides? You see the correct full screen? Okay, good. All right, so I'm going to talk about data centers, and I'm going to talk about how it relates to both the backend cloud and the edge. And I'm going to talk about how we can think about efficiency and emissions in data centers. I think we already had a really good introduction to the topic and a breakdown of where it goes, depending on which layer of the market you're looking at. So yes, there is growth around 20% annually. This is already projected by many think tanks. So this particular one is from Technavio, but roughly there's 20% growth in data center proliferation. There's bigger growth in data and storage, and there's a similar amount of growth in AI. It's roughly 20% a year, which is an exponential. We should not forget that. It's a phenomenal increase in demand. There is also boosting trends, and there's IoT, there is AI, the arrival of the edge clouds, which we talked about already a little bit. And this growth is also putting a lot of pressure, but it's also synergistic with the growth in the back-end data centers, which is where we host all the data. So I want to go over the fact that we talked about data centers. Basically, there were compute centers 20 years ago. The only difference between compute centers and data centers is that compute centers are primarily supercomputing facilities used for scientific computing. The data centers are primarily there to host data. And the goal of the data center is to reduce the cost of hosting data. That's all it is. So if you read early papers from Google, 20 years ago, they said, we want to build computing at a massive scale with a sweet spot on cost. And the sweet spot on cost at the time was a personal computer. So they're basically building these massive computers, data centers, with a personal computer of the late 80s, the early 90s as the building block, because the goal is to reduce the cost of computing. Now, in recent years, what we've seen is a proliferation of various granularity of data centers. And nowadays, edge is becoming really interesting. I'll talk a little bit about edge, but I want to go back that, perspective on, what fraction of this is in the US, what fraction is in Europe. Indeed, Europe did not invest in this early on. So this is one of those investments that we missed on. But now it's coming, and it's coming in the form of two forms of data centers. One is that the hyperscalers are coming to Europe and they're hosting it. They're also in Switzerland. They're coming to Switzerland. They're building them. If you think about what the hyperscalers are building in Switzerland, they're double-digit megawatt facilities, and what they consider an edge data center in Switzerland are the biggest data centers we're building. The second form of data center that's quite common in Europe, which is less common in the US, is the co-location data centers. These are basically not on premises, but you're hosting your server, your IT platform with a co-locator in Europe or in Switzerland. And so by edge, edge for me, even if you host servers at the tower because of self-driving cars, I consider that a data center. It's just a smaller data center. It still requires that you have racks of servers, and it requires that you have hosting capability for those racks, including cooling and electricity. The fundamental thing that's changing in computing, and this is something nobody talks about, is Moore's law. Moore's law is a phenomenon by which we could double the density of silicon for 50 years, and that doubling density came for free. So if I take now Moore's law from 2005, 2015, and if I just double the silicon every 2 years, I get the same rack with 28x density in 10 years, which is a phenomenal, exponential. It's unprecedented in any industry. And this was going on for 40, now 50 years. In recent years, it's slowing down because we're getting to the physics of how small we can make transistors. And because of that, we're now getting a slowdown in the silicon growth of closer to 15% and slowing down to 10%. If I now take 2015, 2025, another 10 years, I'm only getting 4x improvement in the same rack by just relying on silicon and Moore's law. So now if I want to continue the same rate of growth that I had, I need to build 7 racks. So think about that from the perspective, and this is for all digital platforms, not just data centers, but it's a high impact on data centers because they're quite dense in computing. The worst case scenario for emissions is obviously AI right now, besides cryptocurrency. Let's put cryptocurrency on the side because it's bad, but it's not the same level of growth in terms of demand. AI has a huge growth, exponential in demand. And the worst case scenario here is a large transformer model for natural language understanding. This large transformer model has enough GPU cycles that would account for 5 American cars for the lifetime of a car in terms of emissions. The 3 things we need to focus on for data centers is that we need to focus on not just the PUE, because everybody talks about the PUE. That's the electricity you're spending in hosting your servers. We need to think about the servers and the network and the storage and everything else, because that's the thing that's growing. And the PUEs, the data centers themselves are getting more efficient. PUE is going down, but most of your electricity consumption is moving to the servers. So we need to think about the servers. We need to think about heat recycling capability. We have that in Switzerland now. Data centers are being built and connected to the heat centers that are provided by the communities. And we need to think about renewables because that's what's going to cut down the emissions. And we have a certification in place. We've launched it this year. We've already certified HPE data center in Geneva. And we quantify precisely what the full stack, IT and DC efficiency and emissions. So we have the efficiency label and we have a premium label, which is for emissions as well. I will just quickly go over this. I'll tell you that this is what everybody's talking about is PUE. These are actually going down. So this is the less important part of what we need to quantify. What we need to quantify is how much electricity we're giving to our IT. And that's something that nobody's quantifying except for this label. Here's just another slide on the same thing, which is ISO. Everybody is doing ISO certification. That's primarily PUE, which is how much electricity you give your cooling and UPS systems. But we need to quantify what's going into the servers themselves. And also currently the limits that the EU Commission is setting for PUE by themselves is pretty high. Hyperscalers are already operating at the 1.1 range, which again means most of your electricity is going into your IT. So we need to quantify the IT. And for co-locators, which is an important concept in Europe and in Switzerland, we need to be able to certify their DC, but we need to also be able to certify their IT. So if you have an IT as a customer of a co-locator is certified, you can then do a stack certification of your IT full stack with the DC, or as a private customer, you could do both together. This is an alliance of academics and industry, as well as nonprofits. EPFL, EcoCloud, and Hochschule Luzern are from academia. Green ITS, CCA, and Azut are nonprofits in Switzerland from the industrial sector, and then HP is our industrial partner. Thank you for listening to me. I'm really glad to participate in this panel. I just want to thank also our sponsor, Schneider Electric, and the Federal Office of Energy in Switzerland. So that was my.
Thank you very much.
Love to,
Simon, you are working as a researcher on sustainability, and actually you have been one of the contributors to one of the recent publication gathering expert on the topic from EC.
Yes, thanks, Federico. Hello, everybody. My name is Simon Hinterholzer. I'm working at the Borderstep Institute, and as Federico said, I'm doing studies on the sustainability of ICT, and the one Federico mentioned was for the European Commission on the topic of energy efficient cloud computing. We, as a non-profit research institute at Borderstep, we do studies in this topic since 2007. Sometimes we also, we have specific studies for data center energy efficiency, but we also focus on the wider range of ICT as a whole for like end user devices as well, and networks and sustainability, which is not just energy efficiency, but carbon emissions, water usage, toxicity. So that is what we're doing. And quite recent motivation is we realized that like the data center capacities in Germany, they are really fast growing. Like the market is booming right now here in Germany. We're seeing a lot of multi-megawatt data centers, as Babak said already, two-digit megawatts. We have some data centers, even three-digit megawatt centers that are currently built up here. And yeah, specifically in the hotspot areas, like in Frankfurt, for example, we've seen that within 2 years, the capacity of data centers has just doubled. So this growth, this fast growth is not happening everywhere, but in some hotspots, we're having this fast growth that where we even see the energy consumption of data centers is rising really quickly. And we get the data of the electric network operators. And this is kind of alarming data in the context of the goals we have set for climate change, for climate protection. And therefore, yeah, I want to focus on 3 fundamental points when I'm discussing about the sustainability and the climate protection and the climate effects. So as already discussed, the energy efficiency is a really huge part of it. And Babak already mentioned the impact of Moore's law, which is definitely the most important impact for energy efficiency in the ICT itself. Mark already mentioned the different deployment models. If you go from centralized clouds to more decentral deployment models, where you have single companies, or the edge, where even is even further decentralized. Then we have the data center infrastructure, which goes into this efficiency point. And the software, of course, that is operated is highly important. How the software is designed for the amount of resources and compute resources and storage resources and network resources are used. This is causing energy consumption on the physical side. So this is the first major part. Then the second major part that is really important from my perspective is, I think Babak already mentioned that the power production, like here in Germany, from our perspective, we still have a lot of fossil fuels in the power production, a lot of carbon emissions per kilowatt hour that is produced. So the energy consumption is still quite carbon intense. And there we need to get to a much lower carbon intensity in the energy grid overall. And we need to have a 24/7 carbon neutral power supply, and that is not just like anywhere. So as good as possible, we should get to have renewable sources as close by to the new data centers as possible, and as said, 24/7 supplying these data center sites. And the third big point is we need to look at all life cycle stages. I think this hasn't been mentioned yet, that we have the production of ICT, all these scope 3 emissions of these ICT data center operators, that if they buy the ICT equipment from Far East, there is a lot of emissions already within the materials that has been released during the production. There has been a huge toxicity released to the environment, probably by the manufacturing of these ICT equipments. And we also need to look at these points. And of course, in the end, the waste heat was also already mentioned, that we use the waste heat, especially if we build up new data centers. We can look to Scandinavia, where they have best practices how you can do planning of cities, where you put the production of heat from data centers close to the area or to the uses of the heat. So this is quite important that you start this from the beginning, because it's very hard to do this afterwards. If a data center is built up once, this will be very hard to do this afterwards. So that is my introduction. Thank you.
Thank you very much, Simon. Thank you very much, everyone. Babak, we have been talking about mainly the data center, but clearly the digital transformation now is looking a lot at the edge. Our research can look in the direction of energy efficiency and low carbon footprint, while the edge come into the play.
So first of all, I think that it has to do with big data, and I'm glad that we're bringing this up as a panel question in the big data forum. Most of the role that the edge will play, at least when it comes to big data, will be filtering data. And most of the analysis will be done on servers. And the reason is that you would have to, because of, post more means that you have to customize your platforms. You're not going to be able to customize your platforms at the edge with edge devices, sensors, all the way to mobile platforms. You're not going to be able to customize them to be implementing the same services that you would do in the servers. So servers are basically going to be customized to analyze what's coming in. At the edge, you do a lot of inference, you predict and use that prediction to then operate, but you would mostly also filter data and then pass that information back to the edge, back to the cloud. And the cloud would basically percolate from smaller installations closer to your communication points all the way down to the back end. And so it's important to do an efficiency and emissions analysis of not just the large hyperscalers, but also the cloud all the way to where the edge establishes a communication point.
Thanks a lot, Babak. Simon, you in your research, you interact with a big number of actors that are active in the IT domain. And we know that with the transition to the edge, as a matter of fact, the number of actors engaged in the digital transformation process are becoming larger and larger. What is the role of these actors in supporting this transition to be green?
Yeah, like first, when we talk about the transition from the cloud to the edge, like we have to discuss the different edges that will be there and the understanding of edge, first of all, because there is, as Babak already said in his introduction, the edge nodes at the towers of the mobile network. And then we have the network operators, of course, that will be in charge to have these capacities deployed very efficiently, because it's always a matter of the person that operates the physical material, but of course also the software developers that are writing the code that is running on these nodes, on these edge nodes, that these people are creating a software that is very slim, does not need too much of hardware resources in terms of storage or computing or network capacities. So these people are definitely relevant from that perspective of this mobile edge computing. And there is some other types of edge where we have a bit more centralized, like small clouds, which can be in some containerized locations maybe, or networks at like companies that is in the production. So you also have these different people that is not like not similar to a typical cloud environment, which is more again focusing on the specific company, the ICT, like a traditional data center, but in a new form, in an edge decentralized form. So also these people are relevant, of course, if we're talking about the transformation to the edge, I would say.
Thanks a lot, Simon. Moving to Bernard, we already saw that you are working in a challenging domain, which is now really changing probably what will be our life in the next 10 years. And what is the energy efficiency action that your sector is taking on the computational part? Is it something that is you look at, or is something that is maybe a byproduct because you want to have a very efficient hardware for for the cost purpose of the energy and not for the efficiency part per se of the sustainability? What is really the take you have on the efficiency aspects?
Yes, actually, I guess that the automotive industry has really 2 points of views regarding that. There's a vertical perspective and there's a horizontal perspective. To elaborate, just to give you an idea on the vertical perspective, referring to Simon's arguments, of course, for us, it is important to consider the whole life cycle of the vehicle, starting from sourcing of materials to production of the battery, to manufacturing, to operation of the vehicle, to repurposing of batteries, to finally recycling and having a second life of the battery. That is the automotive perspective, the vertical dimension, as I called it. And then, to answer your question, there is also a horizontal dimension. And I think to understand this horizontal dimension, we have to look at specific applications. Let us think on some ICT controller that is doing some thermal management in the powertrain. Think on heating up the battery before charging it to prevent aging or something in that direction. And there, I think we are challenged in terms of having to make a trade-off between computations and processing that we need to do on the back end, so to say, within a cloud environment, or on the edge. There are reasons why you do some computations on the edge. May it be, for example, latency issues, because you need to make decisions in time. There might be some privacy issues, so that you are not allowed to transfer a heap of data to the back end because of GDPR issues or similar things. And then, of course, there is things that you can only compute at the back end. Think on training a machine learning model, because you're doing this kind of training with crowdsourced data from a flood of vehicles, from a fleet of vehicles. So we have to aggregate all the data from the individual vehicles onto a backend and do the training there. So there is lots of constraints that go into the perspective on how to engineer such a solution best, or such an application best. And of course, probably one thing that we should also think on, following EBDVF now for 2 days, I think data sharing has become a very posh topic. There's a lot of discussion on that. And of course, today we are mostly copying data, in the sense that we are moving data from one point to another point, rather than sharing data. And I think by getting more drive into real so let's say domain-specific data sharing, automotive data sharing, we can also reduce the energy footprint, because that would also save energy compared to copying data from one place to another. Yes.
Thanks a lot, Bernard. Marta, in your role, of course, you have quite good understanding of the industry priorities, and I wonder how much is really a priority to support sustainability in the companies, and how much is something that happens by other means, because technologies improve in terms of efficiency and so on. I mean, are we really going to deliver a more sustainable world, or still the economic factor is the real driver?
Thank you. Thanks, Federico. It's a good question. So I would say that definitely, yes, companies are increasingly paying attention to sustainability, at least within their own digital transformation journeys and beyond as well. Partly for the reasons that Monique mentioned earlier, so the regulatory environment, the interest from the finance sector, but also at the corporate level, there's the customer demand. We have data that shows that 60% of European organizations above 500 employees were already incorporating sustainability credentials in 2020 as part of their IT vendor selection process. And in a more recent survey that we conducted in the Nordics, around 47% of IT decision makers were saying that sustainability criteria had the same weight in RFPs for IT products and services as other aspects, such as the technical capabilities, price, and so on. And to me, this is quite significant, actually, of how things are changing. We also see these in the way budgets are changing. So budgets dedicating to sustainability are increasing too. Our own data shows that around 59% of European organizations plan to spend 30% of or more of their IT budgets on sustainable products and services back in 2021, or still in 2021 and 2022. And this can actually include anything from the provisioning of green cloud services to ESG data management capabilities and decarbonization solutions, the use of energy efficient equipment and IoT solutions for smart buildings. You know, the list is quite vast, actually. But I think the overall process is certainly there. We've seen these in terms of what the vendors are doing. And perhaps from our research, one of the most remarkable findings in this process is that there are vast differences as well in the industry within the IT vendors in terms of what type of information they can provide to the customer as well. But also the customer doesn't always understand what they can ask for, and you know, what is the data that is available, and what is data that even if the vendors would like to provide, they really don't have the capabilities today to be able to provide that data. And I think that's part of the problem as well today that we're facing.
Thank you very much, Marta. Monique, the only perspective we didn't touch much is the one on policies, and you are often involved in discussion with the European Commission. So what do you think are the important aspects that Europe as a political and societal entity should look at to ensure that industry, citizen, and other actors are doing their job?
Yeah, well, luckily, it's becoming higher in the agenda of any public authority, from regional to municipalities to governments, the sustainability. So there is an increasing, of course, political attention and political grip. But clearly, when we talk about sustainability and making more greener the whole ICT context, there's a number of aspects that still requires a lot of work, of attention. First of all, because from a technological point of view, as we have heard today from the various presentations, it's not it's not just as easy as it could look like to measure the carbon, the CO2 footprint of ICT. Second of all, because there is still the need to educate not only the providers, but also the consumers. And without educating the consumers towards a more aware choice and behavior, of course, it's also very difficult to make a tangible, a concrete impact. On the other hand, what I think is happening, or what we can see it's happening in Europe, is that, of course, there is a strong push from the European Commission, from several countries, to ensure that there is more compliance to standards, to processes that can be better controlled and measured. But I think what we need to do more is to ensure that there are incentives to create transparency on how energy is consumed in the various stages of the ICT life cycle, from extraction of rare materials to the deployment. And in this respect, this is clearly not an easy aspect, because we need policies, we need regulations at different levels that apply to different players in the economy, from financial investors to end users association, not only to the industrial players and to the small companies. And what we also need, on the other hand, is to make sure that the investments, the public investments, are pushing for greener ICT. So we need to have, from the Commission, from the national governments, from regional and possibly private investments as well, more of an accent on focusing on what are the major research and innovation challenges that still need to be addressed. And today, we've got already a sense that there are quite a few out there that we still need to address. And we should foster more investigation, not only from experts of sustainability, but from experts of ICT together with experts of sustainability, science, economy, and you name it, because it cannot be we cannot find a solution if it's not going to be supported from a multidisciplinary perspective. So in this respect, also research and innovation investments funding should go in that direction. And this is what has been happening definitely more at the beginning of Horizon Europe at the European level. We have seen within Cluster 4, that is the ICT cluster, more specific calls and topics addressing, let's say, more directly addressing the need of green ICT. Not fully explicit, or not enough, I would say, especially if I wear my Digital for Planet glasses. So definitely we need more to create more incentives for more transparency on the one hand, and to ensure that public investment and possibly private investments go more for research and innovation, tackling and addressing areas which are still too poorly investigated, like measuring the internet footprint, measuring the consumer's footprint. There are a number, we have collected a number of papers and reports existing in this area. They are available on the Digital for Planet website. There are more and more of these studies. So I think times are maturing, luckily.
Thanks a lot, Monique. I'm not sure if we are going to have a question from the audience, but meanwhile, I have some question myself, some curiosity. Marta before was mentioning that often IT provider don't have some of the data the customer would like to have available, And this is something as a cloud practitioner, I'm wondering now. I enter in most of the platforms, and of course I get information on the usage of the CPU I'm having, of the memory, of the storage. But so far I haven't seen any of these public platform when I rent some virtual machine telling me how much energy is my virtualized infrastructure consuming. I'm not sure if any of you has a clue why this is not happening. If it's just technical issue, if it's just that they don't think it's relevant.
I'm happy to at least express an opinion. I don't think is that they don't think it's relevant, at least not today. But my view is that from an IT perspective, sustainability is still a fairly new space. So, you know, there are a number of vendors perhaps that were more advanced and were able to provide a higher level of information going back to 5, 10 years. But I wouldn't imagine that the vast majority of them were paying a lot of attention to these aspects 5 years ago. So they're now finding themselves in a situation where they have to gather these type of KPIs, of metrics, of information at a very granular level, and they don't have the necessary skills and expertise internally and knowledge to be able to do so, at least not in the very short term.
Thank you, Marta. Simon, I see your hand raised, so please.
Yeah, I think energy, like the operators of these data centers, they have always been sensitive about giving too much information out about their infrastructures, and about also just the energy consumption could be one of this information. But what I've seen within the last 2 years, that many of the public cloud operators that offer infrastructure as a service services, that they allow their customers to track their carbon footprint within the services. And I think since 1 or 2 days now, AWS is allowing their customers to track that emissions. And I know that Google and Microsoft allowing or having tools for at least assessing the emissions already. So some of them already doing this, like at least for carbon emissions, but of course, this is somehow mixed up with an energy mixture with a carbon emission factor, and you don't see the specific energy consumption as you asked for, Federica.
Yeah, I see. Yeah, I'm an Amazon user mostly, so probably that's the reason why I didn't see anything yet. Back.
Sorry about that. So we've been certifying data centers now for about a year. We launched a label. And we work also with my multiple hats with the hyperscalers. Hyperscalers have, as Mark said, optimized their stacks, but they also have the metrics, and they won't make those available, obviously, to the outside. They're running at PUEs, they're less than 1.1, and they're also optimizing their stack. Because for a hyperscaler, the goal of the cloud is to reduce the cost. The cost for them immediately is electricity, so they don't want to waste any electricity there, which is good. Which also, by the way, again means that when your PUEs are 1.1 or below, most of your electricity is going to IT. So you really need to look at the IT. And when it comes to IT, I would even push the stack a little bit above where Mark put it. I would go to algorithms, because algorithms have orders of magnitude impact on computational requirements. You can just pick AI as an example. If you want to predict an outcome, there are several models and they have different complexities. So same models with different complexities could predict the same exact outcome. But now, talking to stakeholders in Switzerland and also Europe, there are a lot of large DCs that are running at over 1.6 PUE, which is, you know, if you give a kilowatt to your IT, you're getting 0.6 kilowatt to your cooling and UPS systems. And these are, again, these are things that we have measured. The Federal Office of Energy ran a study for a couple of years. They have numbers. They could tell you, here is a percentage of space you can squeeze out of your PUE in Switzerland. Here is a percentage you can squeeze out of your IT. They also did a quantification of IT and how much slack there is in IT. So we have metrics for these things, for data centers. We have them. We can do it today, and we can take it all the way up to the software, and eventually to the algorithms. And today we're doing it, we're stopping at consolidation, virtualization, and containers. So yes, we could do this today. We need to do full stack. EU is still pushing on PUE. And the PUE limits EU is pushing on are really loose. 1.4 is something that hyperscalers were doing 20 years ago. So we need to push for PUEs that are much lower and then do full stack, because most of your electricity is going into the IT.
Thanks a lot, Babak. Mark, I saw also you wanted to say something.
Sure, 2 points. First, you asked the question earlier from a policy perspective to Monique about this topic. And Monique's answer in part focused on research and innovation, but I think there's a real deployment issue. If you look at these data centers, one of the reasons they don't give you those statistics in detail is because they're not instrumented. They haven't wired up their servers to measure voltage, measure power, keep track of things. So it's actually a pretty complicated problem, but actually having data, imagine that, having data on this information, on this, the usage of energy and the usage of the emissions of carbon is very important at a granular level. And managing that is not something that data centers have been set up to do. So as Babak mentions, they are incented economically to reduce their energy, but they're not necessarily incented to help you reduce your energy. They actually charge you for it. So they're happy for you to be extravagant, to be inefficient, because they make more money. So if we can give the customers more tools to improve the efficiency of their algorithms, and I did include algorithms in the software stack, there are things that can be done there. The other point that I wanted to make is that many of the statistics, for example, that you're getting, Federico, they're quite generic. They're at maybe not even at a data center level. They don't relate to, Europe West or something like that. They relate to Amazon's generic relationships to energy and carbon emissions. And so they're just giving you that so that you can fill in, check the box, but it may not be really what you're doing. So there are a lot of moving parts there that deserve both research and deployment support to solve.
Absolutely. Yeah, and given the point that also Babak made on the cost of algorithms, at some point I was looking at the energy efficiency of different programming languages, and I was impressed that one of the worst one is Python. And Python is the most used language in artificial intelligence. So I get a bit scared about this. Then I don't know if Babak now wanted to mention about this or other topics, but I see your hand up. So
yeah, sorry, I don't want to dominate the conversation. I had a point to raise with respect to what Mark said. I was in touch with a big co-locator recently around where we live, and it's absolutely correct. In the case of co-locators, they provision whatever for the customer. The customer is paying for it. The customers are not using what the co-locator is provisioning for, which is why the PUE of the co-locator is high, right? So that's why we need full stack certification, because the customer should also know what they're using. Regarding Python, I'll move to the next topic. Python is a nightmare. Interpreted languages are a nightmare. Python specifically is really bad because Python is one of the interpreted languages for which there is no native compiler. There are variations of Python that give you native compilers that can basically compile directly to native platform and run a lot more efficiently. But the generic Python, which everybody uses, and from an efficiency perspective, is orders of magnitude more computational requirement than what you would run natively.
Yeah. When I read that paper, I was really impressed, and especially compared to Java, because, for example, I believe Java is a monster in terms of resources because you always use a lot of memory, But then I saw this aspect of the energy efficiency, and I said, okay, then Java is not that bad compared to Python. Yeah. And I think we have been talking a lot of the somehow what IT should do, but I think Monique in some point mentioned also the education of people, and all of us here are somehow digital enabled people, and I'm sure this is not just something we need to push to the industry, but also to our private life, and also in terms of digital habits, not just like move to the electric car or use public transport and so on. I don't know if any of you has a take on personal digital habits. Yeah, please, Monique.
Maybe I can say a couple of words about that, because we did some studies on, well, we also studied some studies about digital habits. And I must say that even as what I consider a pretty well-educated digital person, as I feel, I was horrified discovering how bad some behaviors that we all have can be in terms of environmental impact. So I think that we shouldn't give anything for granted in this respect, because there's still a lot of ignorance. We have heard a lot of times, how bad it is to fly, how bad it is to eat meat. But how many of us would give up on some of our bad digital habits, like streaming videos when it's absolutely not needed, or using devices in a totally not energy aware way? And I found that it's very important to also consider that for small businesses, it's important also to identify in which way they can become greener. So the digital behavior does not only concerns final end users, it concerns also smaller companies that, compared to big industrial players, have less means and also less understanding of how they can turn their ICT infrastructure into a greener infrastructure. So there is still a lot of work to be done to empower business players, I would say especially small, medium business players, to identify in which way they can really change the way they do their business, the way they use their ICT infrastructure, and they engineer it.
Thank you, Monique. We have 5 minutes left, so 1 minute again for Mark and Marta, and then we wrap up.
Thanks, Federico. I think in terms of digital habits and some of the studies that I'm imagining that Monique is referring to, for example, the idea of streaming video on your phone and what impact that has, the biggest driver to carbon emissions there relates to the power of the radio networks needed to power that. So the mobile network, and increasingly 5G and 6G. There's been a lot of talk about 5G being very efficient in terms of joules per bit, to use the technical term, but there's a lot of debate also about whether the targets are going to be reached and whether the radio power needed to make this pervasive coverage across Europe, across any part of the world, possible at the kinds of high bit rates that are being touted to consumers. This may be a carbon disaster if we're not careful. It's a big unknown. And I know that BorderStep, for example, Simon has done some analysis of this, and several other people have done it. So the jury is still out. We're thinking it's going to be okay, but it could be bad. And the challenge is when we move everything to the edge and we assume that 5G is going to be our railroad track to getting the data out of from the remote location to some kind of edge data center, that could be a real problem if we don't manage it well. So it needs to be tracked. It needs to be measured right now today. And if there are going to be some problems there, we need to get ahead of this.
Marta, 1 minute for you.
Thank you. So going back to your question about what the impact on our personal use, and I think there's another challenge that we have, both as residential users, but also this is particularly important for SMEs. It's around the creation of infrastructure and ecosystems for what happens to that IT equipment, for example, or electronic equipment at the end of its life. So there's a huge need really for reverse logistics systems, for example, repair and remanufacturing facilities that do not exist today anywhere really at a scale that it's going to be able to facilitate to a large scale part of the problem that relates to areas around electronic waste, for example. So to me, I think that's a fundamental barrier today.
Thanks a lot, Marta. So we are heading toward the end of our session, and I think it was a very interesting discussion, putting together many perspectives from deep knowledge on data center, on general sustainability issues, to specific sector view like the one of Bernard on automotive, policy views, and I think really there is a lot of work ahead of us to make this world more sustainable, and I hope with you and all the others in the community, we are not going to miss the chance to leave a better world to our kids from this point of view, because otherwise I think they're gonna chase us in the next years. And say that, I wish you a nice Christmas holidays and nice festivities if you are not Catholic or Christian. And of course, thanks a lot to all our speakers, Marta, Monique, Babak, Bernard, Simon, and Mark. And I think we ended just on time for the next slot.
Thank you, Federico.
Thank you.
Bye.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.